Good morning, ma'am. My name is Gnaneshwar Reddy from CSE department. Today, my topic is triple integration of spherical coordinates. First, given question is determine the integral 0 to 1, integral 0 to root of 1 minus x square, and integral 0 to root of 1 minus x square y square 1 by root of 1 minus x square 1 minus y square z square dx dy dz by changing into spherical polar coordinates. This is the given question. First, triple integral. Let f of x, y, z be a function of the three variables x, y, z. Define their dimensional finite region between the limits x1, x2, y1, y2 and z1, z2. These are the limits of the triple integrals. First, given integral of 0 to 1, integral of 0 to root of 1 minus x square, integral of 0 to root of 1 minus x square and y square, d and 1 by root of 1 minus x square minus y square minus z square into dx dy dz change into polar coordinates. This is the given. Here x equal to r sin theta cos phi, y is equals to r sin theta sin phi, z is equals to r sin theta, and dx dy dz is equals to r square sin theta dr d theta and d phi. Now 1 by root of 1 minus x square minus y square minus z square is equals to 1 by root of 1 minus of x square plus y square plus z square. Here x square plus y square plus z square is equals to r square. Then this equation changes into 1 by root of 1 minus r square. Limits. R limits is 0 to 1. Theta limits are 0 to pi by 2 and phi limits are 0 to pi by 2. First, this is the x limits, these are the y limits and these are the z limits. First, it changes into the first r limits, theta limits and phi limits, and 1 by root of 1 minus r square into r square sin theta d theta d phi and dr. Triple integral of 1 minus, here plus 1 minus 1 are added. 1 minus of 1 minus r square by root of 1 minus r square sin theta dr d theta d phi. Triple integral of 1 by root of 1 minus r square minus root of 1 minus r square. Separate the denominator. Sin theta dr d theta d phi. One integral is applied, that is r integral. Double integral of 1 by root of 1 minus r square. This is in the form of 1 by root of 1 minus x square. Integral of 1 by root of 1 minus r square is sin inverse r, and root of 1 minus r is equals to r by 2 root of 1 minus r square plus 1 by 2 sin inverse of r. And limits are 0 to 1 and sin theta dr d theta and d phi. Next, double integral of, so after solving that equation we obtain pi by 2 minus pi by 4 sin theta d theta d phi. Here after solving this pi by 4 is obtained. Pi by 4 is the constant, that's why we write outside the integrals double integral of sin theta d theta d phi. Now we apply in the d theta. Pi by 4 into phi integral of cos sin theta integral cos theta 0 to pi by 2 and d phi. Here minus pi by 4 integral phi of applying limits. Upper limit cos pi by 2 0 cos 0 1 minus 1 minus we write the outside the integration, that's why minus pi by 4 integral of 1 d phi minus pi by 4 integral of d phi. Here there is no value and variable. That's why here assume 1. Integral of 1 d5 is pi by 4 of d5 0 to pi by 2. Apply the limits. Pi by 4 into pi by 2 minus 0. Multiplication of these two, we obtain pi square by 8 is obtained. Thank you, ma'am.